Remember that movie about the kids being shrunk?
I shrunk the kids, threw them out with the trash.
Yep. Well, the ability to do that sort of stuff is now almost a reality. It's called implosion fabrication. It sounds like something out of a science fiction novel, and on Thursday, December 13th, 2018, a paper was published by an MIT team who had tested the technique of shrinking objects. According to the paper, they managed to shrink material attached to a piece of polyacrylate to a 1,000th of its original size. And that's quite impressive. So how does this work exactly? So unlike the name, which sounds like something you would need a PhD to come up with, let alone actually understand, the process behind this can actually be broken down into simple terms. According to the document, the objects tested, in this case pieces of polyacrylate, were placed into a bath of liquid solution, which caused the material to expand. The object was then spotted with a laser, which causes fluorescein molecules to bind to it, which depends on where the laser has been spotted on the object. And it's these modules that, according to the research team, act as anchor points for the scaling of the material you're wanting to shrink. Following this, the material was attached to these anchor points, and using an acid, the polyacrylate was dehydrated. It's at this point that it gets a bit confusing. The dehydration process of the polyacrylate caused the material anchored to it to shrink to exactly a 1,000th of its original scale. The possibilities as to what can be scaled are technically endless, as the polymer scaffold used for the scaling process can be patterned by the laser in basically any shape, which is also quite impressive. A big challenge up until this point was actually creating the patterns used for scaling. According to the paper, dotting a pattern in 2D has always been easy. However, creating a 3D scaffold is incredibly difficult and time-consuming. It's a process of layering many of these 2D patterns into a 3-dimensional shape. To overcome this major limitation, the team decided to implement a technique known as expansion microscopy, a technique which has been around for a few years. It essentially works in the opposite way to this method for shrinking objects. It's also a bit simpler. Rather, it causes the objects to swell and expand while keeping the original shape. This was super beneficial to scientists trying to observe very small objects, as some objects are smaller than the actual diffraction limit of microscopes, meaning that a microscope just can't be used to observe them, and obviously that creates a lot of issues. With this expansion technique in play, the materials could now be scaled to an easily workable size, and the previous challenges of creating 3D scaffolds were no longer a problem. And here we are. It's at this point that it's worth noting that the really amazing thing about this process is that the team at MIT believes almost any materials science labs should have the necessary equipment to begin experimenting with this process on their own. Like the majority of new scientific discoveries and announcements, the current results seem amazing while also underwhelming the expectations a little bit. But this is just the beginning of a much bigger development. And as the MIT team responsible for the paper have put it, there is no limit on the possibilities. So who knows where this could go in the future.